give you is y equals 3 to the x is transformed to y minus 3 equals 2 to the 1/3, negative 2x plus 1. I want the transformations and mapping, and then I want the asymptote, and then I want domain and range. What do I have to do first before I can actually state the transformations? Get y by itself? Sorry? An x by itself, so to get like a 1 in front, but I also have to do what? Because this is exponential. Same base. So remember that 1/3 has to turn to a 3, which is going to mess up with your, what's it called? Deflection. So I'm going to add the 3 over, so I'm going to get y equals 2. I'll leave the 1/3 for now. And I take a negative 2 out, and I'm going to get x. Now 1 divided by negative 2 is negative 1/2. Bless you. Plus 3. Now I can't leave it as a 1/3. If this is base 3, this needs to be base 3. The 3 appears nowhere in there, but you can't compare them unless they are base 3. So in order to make it be 3, we have to make it 3 to the negative 1. So if I go 3 to the negative 1, my negative 2 is going to actually become 2, and I won't have a reflection. Okay? So you have to watch yourselves. They have to have the same base. I'm going to do this over and over and over until you stop not doing it. So you start doing that. So I should say, not stop not. Okay, transformations. We have the 2 in front and the 2 in front. So the 2 in front of the 3 is a vertical stretch by a factor of 2, because they always stay the same, about the x-axis. My horizontal always flips. So I have a horizontal stretch. I have to go stretch, reflect, translate. Horizontal stretch by a factor of 1/2 about the y-axis. I have no reflections, they're both positive. I have a horizontal translation. One half right. Units right, I should say. And a vertical translation three units up. So my mapping, my x, y, is going to become whatever affects the x in here. So if it's 2 and negative 1/2, it's actually going to be 1/2 x plus 1/2. And then my y is going to be 2y plus 3. This is an exponential graph, correct? Exponential graphs have what type of asymptote? They have a horizontal asymptote. This is just the base function. I'm not drawing this one. Okay? They have a horizontal asymptote on the x-axis, so y equals 0. And they're either increasing if b value is greater than 2, or they're decreasing if the b value is less, between 0 and 1. Right? Increasing if the b value is greater than 1. So our b value is greater than 1, so I know it's an increasing exponential. We agree? What gets me the asymptote? Do you remember? Yeah. The vertical translation. So it's a horizontal asymptote. That's not going to change when it's exponential. And it's not going to be at y equals 0. It's going to be at y equals 3 because it moves 3 up. What's my domain of every exponential function unless it's a word problem? XCR. In set notation, in interval notation, negative infinity, positive infinity. Now my range is always greater than, not equal to, because it's a dashed line, an asymptote, right? Greater than the asymptote, unless there's a reflection which causes it to go down. What causes a graph to go downwards? reflection in the x-axis, so I need to have a negative with my y, right? Do I have any reflections here? No, this is like the nicest thing ever, because it has to be greater than, I can't even mess up the reflections because there isn't one. So it's going to be y such that y is greater than my asymptote, 3 YER. And the other thing to remember is, if I want to change my range, it has to affect my y's, correct? So my negative has to be with my y in order to flip the inequality sign. If it's with my x, it's not going to affect my range, it will affect my domain. Except this one's x, yeah. Greater than 3 is 3 to infinity in integral notation. Okay, question 2 for you to try, and 3. 2, I'm going to get you to solve. 4 times 2 to the 3x plus 1 over 16 to the 2x plus 1 equals 8 to the x plus 3. I want you to solve that one. How are we going to solve it? By common base. What base can we make them all be? 2. And 4 becomes 2 to the what? 2. And then what am I going to do with these two exponents on these? Add. Yeah. Okay, and then we'll, when we divide, we subtract. So that's number 2. 3. Rita invests $3,000 in a GIC, which has an interest rate of 2% per A, which means per annum, which means per year, which doesn't do anything, compounded quarterly. How many years will it take in years full year for your investment? Worth 4,500. We'll go through this first one. So we can make them all be base 2. We said that already. So we have the 4 is 2 squared. And that's going to be multiplied by 2 to the 3x plus 1 over 16 is 2 to the 4 to the 2x plus 1. And then 8 is 2 to the 3 to the x plus 3. So we can make the top ones go together. They're being multiplied. So you have to have same base, same exponents, right? Same base, same exponents. When I'm multiplying, I add the exponents. So I'm going to get 2 to the 3x plus 3. And then here I only have one base and then exponents, so I multiply. 2 to the 8x plus 4 equals 2 to the 3x plus 9. Now I have two bases that are the same, but I'm dividing. So when I divide, what do I do with the exponents? You subtract. So we're going to get 2. 3x minus 8x is negative 5x. And then 3 minus 4 is negative 1 equals 2 to the 3x plus 9. Now I have one base to an exponent, one base to an exponent. What can I do? Only now set them equal. It has to be one base, like base 2 to some exponent equals base 2 to some exponent, then the exponent's equal. So we're going to get negative 5x minus 1 equals 3x plus 9. And then we solve. So I'm going to add 5x. Negative 1 equals 8x plus 9. Subtract 9. Negative 10 equals 8x. Divide by 8. And x equals negative 5 over 4. Which is negative 1.25. Now you should be able to type the original in, second trace 5, enter, 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 and get the right thing. Did you get negative 5 over 4? You should plug it in. If you have the fancy calculators, these are actually easy to plug in because you can just go second or alpha y equals enter and get fractions and make it look like that, right? The other ones, the older ones, it is harder. Okay, we went over doubling, tripling, half-life one on Thursday. Today I picked a compound interest one. I told you you're going to have one of each type. So if you're like, I wonder if she's going to put one of each, she is. She said it twice now. So she's telling the truth. She's me. Okay. So Rita invests 3,000. So that's my initial in a GIC, which is just a type of investment, which has an interest rate of 2% per annum. So my little I is going to be 0.02. Compounded quarterly, CP is 4. How many years with it take? Come on, Lepp. Will it take the nearest whole year for her investment to be worth 4,500? And then T or N equals question mark. So we fill it in, we get final, which is 4,500, equals initial, which is 3,000. That's a large increase. You're like trying to get almost half of what you initially came in with, right? So that's a large increase. It's going to take a long time because 2% interest is not very much. 1 plus 0.02 divided by 4, and then n times 4. So the first thing I do is divide the 3,000 over. And I'm going to get 3 over 2 equals 1.005 to the 4n. Now I told you can y1, y2 this, but now we can actually solve all of these word problems algebraically. After you've done this, what do? We convert it to a log. Convert to a log every single time. Remember? The base of my exponent becomes the base of my log. So I'm going to get log base 1.005. What's with it, friends, when their exponential isn't going to be friends? So the 3/2 is going to go here. Or we can do 1.5. It's the exact same thing. And it equals the exponent. And it equals the exponent because that's the reason why you convert to a log is to get the exponent to come down. And then we divide by 4. If you have the old calculators, you're going to have to go log 1.5 divided by log 1.005, enter, divided by 4. But I have the new one, so I'm going to go log base from my math. So it takes 20.32389641. In order to walk out of the bank with $4,500, can she walk out at year 20? At year 20, will she walk out with $4,500? No, she's going to have to wait till 21. Because 20, she actually won't walk out with 4,500. Okay, I'm going to get you guys to flip to your notes then, once you have that. So this is a little reminder. You're also going to have a piece of paper because we're going to do some practice on the stuff we've already done. And a little reminder was, if I have logs with the same base, they have to have plus or minus ones in front of them in order to get put together. Correct? So it will scream, put me together, but they have to have the same base and plus or minus ones in front. So if I give you this, 2 log base 6 of 4, I'll do it with just numbers for now, plus 3 log base 6 of 2, minus 2 log base 6 of 3. I want you to write this as a single logarithm. Or I could say simplify. They're all the same base, so that's good. What's my problem? I can only put them together if they have the same base and what in front? Ones. What do I currently have? A 2, a 3, and a 2. I don't care about the positive negative signs. I just care about the numbers. Now the rule on your page in front of you says that I can move those so that I have plus or minus ones. Where do I have to move them to? To the exponent, right? I can move them up as an exponent only with the word log. When there's a log word in here, I can take this and move it up. Take this and move it up. Take this and move it up. So I put an equal sign because this equals log base 6 of 4 to the 2 plus log base 6 of 2 to the 3 minus log base 6 of 3 to the 2. Remember that? I'll come back to you. So anything with a plus 1 in front, so we get a single log now. Log base 6. Anything with a plus 1 in front goes to the numerator. Anything with a minus 1 in front goes to the denominator. And if there's more than one thing in the numerator or the denominator, what do I do to them? What operation do I do if there's more than one thing in the numerator or the denominator? Multiplication. So I have a plus 1 in front of this one. So the 4 squared is going to go to the numerator. I have a plus 1 in front of this one. So the 2 cubed is going to go to the numerator. And then I have 2 things, so I'm going to multiply them. This one has a minus 1 in front, so the 3 squared goes to the denominator. So then we get log base 6. 16 times 8 divided by 9. You get 128 over 9. Done. Remember those rules? Slightly coming back. Okay, what if I don't give you numbers beside and I give you variables? So we're going to try number 2. Negative 3 log base 6 of A plus 2 log base 6 of B plus 2 log base 6 of A minus 5 log base 6 of B. Try that one out. So I told you to move the number, not the sign, right? You can move the sign, but you will confuse yourselves. You won't know what to do with the negative A or whatever. So it's easier if you just move the number and then say, hey, there's a negative 1 in front, it drops to the denominator. If you leave it as a positive 1, you'll have a to the negative 3, and then you'll have to move a to the negative 3 to the bottom to make it positive, and people will mess it up. So I never move the symbol, just the number. So it equals log base 6. Now I have a negative 1 in front, so the a cubed is going to go on the bottom. Here I have a positive 1 in front now, so the b squared is going to go on the top. Here I have a positive 1 in front, so the a squared is going to go on the bottom. And then I have a negative 1 in front, so the b5 is going to go, oh, come on, let even positive 1. Positive 1 in front, the a squared goes to the top. That was a spoke wrong. And then the negative 1 in front, so the B5 goes to the bottom. Now, we have some B's on the top, some B's on the bottom, some A's on the top, some A's on the bottom, correct? So we can cancel out. So, I have 2 A's on the top. I can cross off 2 of these A's, so I'm left with a 1. I have 2 B's on the top. I cross off 2 of these, I'm left with a 3. Now, what you always often forget is those slashes that you're making through them that cancel them off are actually slanted ones. Every time something cancels, you're left with a 1. So this is like a 1 times a 1. So in the numerator, what are you actually left with? A 1. It doesn't just go away, which I will give an option of the numerator gone in the multiple choice. I will. You pick it and you'll be wrong. Because these slash numbers are ones. So 1 times 1 is a 1. A, B cubed. Done. Okay. Another rule we went over is if I give you this. So if I give you log base 3 of 9. What is the answer without us actually having to type it into our calculator? What does it do every time it does this? When you, yeah, so you're saying 3 to the power of blank equals 9. So 3 to what power equals 9? 2. So the answer is 2. So if I have like log base 2 of 16, 2 to the power of what is 16? 4. And then if I had like log base 4 and a quarter, 4 to the power of what is a quarter? What makes a thing flip? Negative 1. What about if I give you this? Log base 6 of 1 equals. 6 to the power of what is 1? 0. So whenever you have a 1 beside 0, so often it'll look like this. They'll go log base A of 1, and then people are confused. They're like, I don't know what that is. A to what power is 1? 0. Whenever there's a 1 beside your log, your answer is always 0, because anything to the power of 0 is 1. The other rule that everyone forgets is if I give them like log base A of A to the 6. Your answer just can be 6. Because you're going to say A to what power gets me A to the 6? 6. The other way you can look at it is, instead of looking at it that way, you can go, okay, log base A of A to the 6. I can take the 6 and I can drop it in front. So now I have 6 log base A of A. What's log base A of A? It's a 1. So it's just 6 times 1, which is 6. So you can do it either way. But if you ever go log A to the 6, your answer is 6. So if I give you this, log A to the B, what would my answer be? B. A to the B, your answer is B. So whenever these are the same, your answer is just the exponent. Okay? We went through rules like that. So we're going to go to the notes. We're going to go back to our notes. I think it was example 3, right? Is that where I was at? Okay. So example 3 says, write each expression as a single logarithm in simplest form. So in order to write as a single logarithm, what are our rules? They all have to be the same base, and they all have to have what's in front? Plus or minus 1. Now this one is confusing, because it's 5 blah 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 over 2. How could I rewrite this so it's not confusing? Yes. So log 7x squared plus log 7 base 7 of x minus 5 over 2 log base 7x. I want you to try these two. I want you to try A and B. They're a little bit different, but they just follow the same rules. So this one we have log base 7 of x squared plus log base 7 of x, and then I need to move my 5/2 up, minus log base 7 of x to the 5/2. And so I'm going to get log base 7 x squared times x over x to the 5/2. This is x to the 1. Now, when they don't have an exponent, my hint to you always is to put a 1 on it. Because what you're going to do is you're going to forget to actually add them. And so then you'll leave it at like a 2 or something. So we're going to get log base 7. These are common bases, so we can put them together. This can be x to the 3 over x to the 5/2. And then what do I do when I have two x's and I'm dividing? Subtract. So I'm going to get log base 7. X to the 3 minus 5/2 is x to the half. Done. How else could they write this? They could take that half and now drop it in front and go 1/2 log base 7x. Right? They can take that half and drop it in front. Just looks a little different. It's still right. Now B, they're both log base 5. It has to scream to you. When you're reading it, it's like log base 5 of blah minus log base 5 of blah. When it says, when you're saying the same base twice, they will be put, you will have to put them together. That is what's going to happen. So when you see the same base, it needs to scream, put me together. Okay? So this one has a +1 in front. This one has a -1 in front. So I'm going to get log base 5. In the numerator, I'm going to have 2x minus 2. In the denominator, I'm going to have x squared plus 2x minus 3. And I have to make sure I have an equal sign running down the left side because these are equivalent. The top equals this, equals the next, equals the next. They all equal, right? They're just a different way of writing it. The top, the numerator, I can take out a 2. And I'm left with x minus 1. The denominator factors to x plus 3, x minus 1. The x minus 1's cancel, and I'm left with log base 5 of 2 over x plus 3. Done. Then we're going to flip over. There's a your turn on the back. Try it out. Remember, with C, you're going to have to distribute the -1/2 into both of your logs. So for this one, that -1/2 is going to have to go in first. Right? So this one, we're going to get equal to 4 log base 3 of x minus 1/2 log base 3 of x minus 5/2 log base 3 of x. Now I'm saying log base 3, log base 3, log base 3. I'm hoping that that's screaming, put me together in your heads when you're hearing log base 3, log base 3, log base 3. Now we can't put them together unless we have plus minus. 1's in front, so we're going to move these up to the exponent. So I'm going to get log base 3 of x to the 4 minus log base 3 of x to the half minus log base 3 of x to the 5/2. And so we're going to get log base 3. The x to the 4 has a +1 in front, so it's going to the numerator. The x to the half has a -1 in front, so it's going to the denominator. The x to the 5/2 has a -1 in front, so it's going to go to the denominator. So I'm going to get log base 3 x to the 4 over, now I can add those. X to the half times x to the 5/2 is x to the 6/2, which is actually x to the 3. X to the 4 minus x to the 3 is log base 3 of x. Finito. So something way bigger that actually turned into just a nice answer. Now, you know how you can find out if you made a mistake whenever you're doing equivalences? So solve, you can figure out how you make a mistake when you get an answer and it doesn't match. Because you can go left, you can go y1, y2, find out where they intersect, correct? Every time it says solve, you can always check. You can also check where you made a mistake in simplifying. The only thing you can't have beside a log is a negative number. Okay? You can't have a negative there. You can't go like log base 6 of negative 4. It's not possible. But you can plug anything in for x you want as long as it doesn't make a negative. Right? So we're going to try this out. Every single person is going to grab their calculator. It's way easier if you have the fancy calculators as opposed to the older ones. Sorry, for the older ones, you're going to have a lot of brackets. But you can plug anything in for x. So you could plug in, say, 2, right? So you could go 4 log base 3 of 2 minus 1 half log base 3 of 2 minus 5 halves log base 3 of 2. And it should match this first step because they're equivalent, aren't they? They'll give you a decimal. The decimal should match. So you'll know where you made a mistake. You know when they do simplifying and they say, where did the person make an error? You know those questions? Like, which step did they make an error? Well, you can plug something randomly in for x. Plug it into the first step. Get a decimal. It'll be like 1.7. Plug it into the next step. Get a decimal. It should be 1.7. Plug it into the next step. You get a decimal. 1.7. Plug it into the next step. You get a decimal. 2.7. There's the error in the step. Right there. You can check your error steps by just literally plugging in and seeing if you get the same decimal from step to step to step to step. So when you're simplifying, if you want to know if you're right, plug it in, boom, 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 boom for x. It just has to actually work. It has to be an x that works. It can't be a negative. If you have the older calculators, that is a lot of brackets, and I don't know if it's worth it. I think I would not want to type it in. Okay. This one, we have a plus 1 in front and a minus 1 in front. So we're going to get log base 2. In the top, we're going to get x squared minus 9 in the numerator. In the denominator, we're going to get x squared minus x minus 6. Then we have to factor it. The top is a difference of squares. We're going to get x plus 3x minus 3. The bottom, we're going to get, well, multiply is going to be negative 6, now it's going to be negative 1. It's going to be x plus 2, x minus 3. Then the x minus 3's cancel. And we get log base 2, x plus 3, x plus 2. Most people are decent at spotting the put me togethers. But they'll mess up. Like if this is like a plus, a minus, and a plus, or in this case, they forget to distribute it and say it's a plus. Or if it's a plus, a minus, and a minus, they won't make the second minus drop to the bottom. I find that's the common error. People don't like, if there's a plus 1 in front, it goes to the numerator. If there's a minus 1 in front, it goes to the denominator. Sometimes you guys forget that rule and just put some of them in the numerator. Okay? But most people will spot put me together when the bases are the same. Okay? What people won't do is example 4. They'll forget that you can actually separate them. Okay? You can separate them by plus or minus signs. This is what I want you to do every single time. When a log doesn't have a base, what should you put? 10 every single time. It will make your life better, I promise. So I'm going to rewrite this as log base 10. And then this is the other thing you should always do. What's being multiplied here in that numerator? We only have a numerator, but what's being multiplied? The 100, the a, the b squared. Do you want to know what people often do? They'll put the 100 with the a. Why is 100 with the a? Why can't it be with the b squared? It shouldn't be with any of them. They're all multiplied separate entities. So this is what I'm going to get you to do, and this will make your life better if you do it every single time. You put multiplication signs between every single thing. So 100 and a are not attached, just like 100 and b squared are not attached. They're all multiplied by each other, are they not? So I'm going to do this, and if you do this, most people will not make the error. If you don't do this, most people will continually put the 100 and the a together. So what am I going to do? I'm going to go 100 times a times b squared. Do you see that? 100 times a times b squared. Now I know that when I have anything in the numerator or the denominator, I can separate them out by plus or minus signs. We agree? A whole bunch of logs. I can make one single log be a whole bunch of logs. I just made a whole bunch of logs be one single log, didn't I? So I can do the reverse. So what do? These are all in the numerator, aren't they? So what are they going to get in front of the log? Plus 1s. Every single one is going to get a plus 1. We agree? So everyone's really good at seeing a whole bunch of logs making them 1. What you're not good at seeing is seeing 1 and making it a whole bunch of logs. So let's do that. So we're going to get log base 10 of 100. And what's sitting in front of it? A plus 1, if we want to show it. Then the a and the b squared are all also in the numerator. So what are they going to get in front of their logs? Plus 1s. So I'm going to get plus 1 log 10 base 10 of a plus 1 log base 10 of b to the 2. Log base 10 of 100. That's all numbers. There's no variables there, isn't there? Is there numbers or variables with log base 10 of 100? No. You can type it in and get an answer, or you can say 10 to what exponent is 100? 2. So this turns into 2. 2 plus log, do I need to write the base 10? Are they going to write the base 10 in their answer key? No, they're going to go log a. The 10 will go away. But do you see how I needed the 10 to realize that this is 2? If I put that 10 there, I'll see it's 2. If not, even if it's just a number, type it in and see if you get a whole number. If it's all just numbers with a log. And then this one, how could they write this one? 2 log base 10 of b, or they can just not write the base. They can make the 2 come in front and go 2 log b. I want you guys to try example 5 and example 6. See what you can do. All right, let's expand this one out. So what I would do immediately when I see this is I'm going to go log base 5. Then I'm going to go 25 times m cubed over n. I make sure to put a dot in there so I realize, hey, I'm going to have 3 logs. Right? When I expand this, I'm going to get 3 logs. Not 2, 3. So this equals log base 5 of 25 plus log base 5 of n cubed minus log base 5 of n. Log base 5 of 25. 5 to what exponent is 25? 2. And then I can take that 3 and I can do what with it? Drop it in front. So I'm going to get plus 3 log base 5 of m minus log base 5 of n. And it matches C. Example 6 is a little tricky. So if I give you this, remember this. So say I gave you this. Square root of x. What did I tell you you could write that as? X to the what? 1/2. So if I gave you a 3 here and a 2 here, I could write this as x to the 2/3. Because the 3 just drops under. That's all you did in grade 10. Just drop it under, drop it under, drop it under. If you remember it or if you even learned it, I don't know. So if we have this, the 8th root of b, how could I write that? B is to the power of 1. So this is b to the 1 over a. That's all it is, right? Every single time we're doing these, we're just take our exponent, drop it underneath. I hit my watch on it. Take our exponent, drop it underneath. Take our exponent, drop it underneath. Correct? So what's this one going to be? Log base a of a to the what? This a is to the 1. So what's it going to be? To the 1 over b. What can we do with this 1 over b? We can drop it in front. So we can get 1 over b log base a of a. What do we get when it's log base a of a? That's a 1. So what's my answer? 1 over b times 1, which is? 1 over b. Example 7 I starred because it's hugely important to be able to do example 7, not for today's homework, but for tomorrow's, to be able to solve. We go to solve logs. I want you to write this as a single logarithm. Currently, I have log base 6, and something without a log base 6. So what do you guys do? You'll have to put the log base 6's together and then leave the 3 out. That's not a single logarithm. That's a 3 with a logarithm. Correct? So what do I need? I need that 3 to be a base 6 somehow. Because if it's a base 6, Then I'll have log base 6, log base 6, log base 6, put them together, right? We just did that. That was easy for us. So, off to the side here, I'm going to say, okay, I need 3. I need 3 to equal log base 6 of something, right? Because if I can swap my 3 out with log base 6 of something, I'm in a good place. We agree? What needs to be beside the log in order for it to be 3?
216.
216. How did you do that?
6 cubed.
6 cubed. Because what did I do? I said 6 to what power gets me this, correct? I need the answer to be 3. So if I just make this 6 to the 3, 6 to the 3 is 216. Now I can go 6 to what power is 216? And it is 3. You just raise this to the 3. I need the answer to be 3, correct? So 6 to the 3 is 216. So now I can say 6 to the what is 216? 3. Well, I just made it be that way, right? So now instead of a 3, I'm going to replace it with log base 6 of 216. Because log base 6 of 216 is 3. So I take the 3, I toss it out, and I replace it with the base 6. Then I get minus log base 6 of a. And then this 2 comes up, and I get plus log base 6 of b squared. And I had to make the 2 come up. Now, can I put them all together? Yes, because they're all base 6s. You see that? Base 6, base 6, base 6, all have 1s in front. Plus and minus doesn't matter, but they just need to be 1s. So now I'm going to go log base 6, 216 goes on the top in the numerator because there's a plus 1 in front. A goes in the denominator because there's a minus 1 in front. B squared goes in the numerator because there's plus 1 in front, and I'm done. You guys try B. You're going to have to make them all be base what? What base are these if there's no base? Base 10. Base 10. You need to make that one be a base 10. So I need to change 4 to be log base 10 of something. To find this something, I just raise it to the power that's over here. So I go 10 to the 4. 10 to the 4 is 10,000. Then you can check it and see log base 10 of 10,000 and see when you get 4. So now we're going to get, the 2 has to come up, the third has to come up. So we're going to get log base 10 of b squared minus log base 10 of c to the third minus log base 10 of 10,000. And I'm going to get log base 10. B squared stays in the numerator because there's a plus 1 in front. C to the third goes to the denominator. And then 10,000 goes to the denominator. What am I doing? So the way this will often be written is log. They won't put base 10. If it's a base 10, they will not put base 10 for you. Like we have base 10 in there to help us out. They'll drop the 10 back off. So if we go log base, nothing. Then we'll have b squared, and then they'll have 10,000 on the bottom. C to the third, what might they change it to? They'll bring the 3. They'll bring the 3 in front of the radical, right? A third is the same as what? A half is the same as the square root. A third is the same as a cube root. Now 10 and 11 say state restrictions. I'm not concerned about the restrictions for now. We're going to talk about restrictions when we go into solving, which we're going to start tomorrow, solving logs. So don't worry, where 10 and 11 says and state restrictions, don't worry about the restrictions. You're just going to have to put them together. Those are all the ones you put together. And then number 8 is a take apart one. So 2, 3, 10, and 11, you're making, you're simplifying to one log. And then number 8, you're making logs. Okay?